Good evening, everyone. Can everyone hear me? How are you guys doing? Surviving, nervous. I assume, how's the exams going? Not too bad. So, a few details about the SEI exam. The exam is this Wednesday from 11:15 to 1:15. That means you have 2 hours to do the exam. The exam will be worth roughly 60 marks, and it will have the exact same format as the semester test, and it will cover everything we've done during the semester. So everything. So you'll get your formula sheet that is included. And don't overthink it. Just understand what's being asked. So, do you guys have any questions before we go through the memo of the mock exam? How many marks are the MCQs? So, that will, if I remember correctly, that will be roughly 50 marks of the 60. Sir, would it be any calculations in long questions? No calculations in the longer questions. The only calculations will be, for example, is if you have star A and star B, how many times more bright is star A and star B? If I give you, for example, distance, what is the orbital period? So Kepler's third law, those type of questions. So yes, 50 out of the 60 marks will be multiple choice. So that question about which stars faint or bright in a memo of the semester, is that correct? Yes, that is correct. So to go through that, go visit the appropriate chapters, reasoning with numbers. So we will do another question like that in the mock exam. Marks distributed, 60 marks more or less, and 50 of those marks will be multiple choice. Pleasure. So let's go through the mock exam. Did you guys at least try to attempt the mock exam? Not yet. So it's not difficult. Let's go through it. So the first question you should be all be able to answer after your moon assignment. Let me get a pen out. Uh, let's get that ready. So the first quarter moon rises when? At about noon, at sunset, at sunrise, about midnight, during the second week of each calendar month. Yes, you are correct. The answer is A, at noon. In question number 2, star A has an apparent visual magnitude of 13.4 and star B has an apparent visual magnitude of 15.4. So star A is what, then star B? So already from the get-go, which star is more brighter? Star A is brighter than star B because, remember, apparent visual magnitude, if it goes to more the negative side, it is more brighter. So star A is more brighter than star B. So from that, we can already eliminate that star A is 2 times fainter. That is wrong. Star A is 2 times brighter, could be. C, fainter, that's wrong. And E is fainter, that's wrong. So the only two options remaining is star A is 2 times brighter than star B or 6.3 times brighter than star B. So which one is the correct answer? Yes, you guys are correct. If you plug it into the formula, we'll realize the correct answer is number D. Well done. So, question number 8. This is just plain arithmetic. If light takes 8 minutes to reach Earth from the Sun and 1.3 hours to reach Saturn, what is the distance from the Sun to Saturn? Yes, you are correct. The correct answer is C. Then question number 4. What is the approximate age of star cluster if the turn-off point lies with the spectral type G stars? So yes, number C is correct because all the G-type stars are some of the oldest stars that we can observe. So the universe is not 100 billion years old. It's only roughly 13.8 billion years old. 2 billion years is too short. 2 million years is too short. And this is not applicable. So the correct answer is number C. Should we know for all stars? So remember, turn-off points of the clusters, type G stars. That's something we've learned in class. G-type stars are some of the oldest stars we can observe. So a question, can you go through how question 3 is done? That's just plain easy arithmetic, but we can do it. So we know the distance from Earth to the Sun is 1 AU, right? So 8 minutes equals 1 AU. So now we can say 1.3 hours equals what? But we have to equate it to everything to minutes first. So we have 8 equals 1. So how many minutes is 1.3 hours? Yes, 78. So 78 equals, let's call this x. So we cross multiply. So we have 8x equals 78. So x equals 78 divide 8. And that should give us x equals to 9.75 AU. Does that make sense? Awesome. Question number 5. Which star with absolute magnitude given below has the greatest luminosity? What would you guys say? Which one of these stars has the greatest luminosity? That would be number D, because it's the largest negative number. So looking at the magnitude scale, that will be the most star that has the most luminous. Happy with that answer? Awesome. Question 6. If a sunspot has a temperature of 4,500 Kelvin and a surrounding solar surface has a temperature, that's a typo, that must be 5,800 Kelvin. How many times brighter is the surface compared to the sunspot? Number C, yes, that is correct. So to do that, let me just get the formula. So you will use this equation. So let me just get something to write with to show you how to do the calculation. So from this equation, we are going to use a relationship. So we're going to say it is E2 over E1. So that will equals, so the Q, this will be 1. If you substitute that constant in, so that will be T2 to the power 4 over T1 to the power 4. This will be 5,800 to the power 4 over 4,500 to the power 4, and this will give us 2.75, and that is rounding it to 2.8. Happy how we got the answer? Yes, I will upload the recording directly after the lecture. So, question number 7. The options below list the spectral types of 5 stars. So, which one has the lowest surface temperature? So, remember our little rhyme scheme. O, B, A, fine, girl or guy, guess me. So, with this, it would be number C, correct. Question 8. What would be the phase of the moon if it was observed at a vernal equinox on the 21st of March? So the correct answer here is B, a new moon. Then question number 9, star A. So that is just something in the moon cycle every year time. So every time is the vernal equinox, it will be a new moon. Not really. Vernal equinox is when we have in South Africa the Tropic of Capricorn. So that is in the southern hemisphere when you have the turning point between summer and winter, and going into fall. And then we have another one again on the 21st of September every year. So in March it's the vernal equinox, and in September it's the spring equinox. It's a pleasure. So in Afrikaans, die steenbok skeerkring. So in question 9, star A has an apparent visual magnitude of 15.4, and star B has an apparent visual magnitude of 12.4. So this already tells us that star A is brighter or fainter than star B. Yes, star A is fainter. So that means we can automatically cross out everything that has a brighter in. So that means star A is 3 times fainter than star B, 16 times fainter, or 14 times fainter. So yes, the semester test memo, I know there was a mistake, but I corrected that for everyone. So for this, which one is the correct answer? Yes, it's C. It's 16 times fainter. So question number 10. What is or are the hot gases that are the moving extension of the sun's corona? Yes, you are correct. Number E, that is the solar wind. Question 11. What is the predicted end of a white dwarf? Yes, number B is correct. A black dwarf after a long time. Question 12. Star clusters are important to our study of the stars because it is C. They give us a method to test our theories and models of stellar evolution. Question 13. How does a gas cloud become hot enough to ignite nuclear reactions? And that is number B, through compression by its own gravity. Question 14. On the HR diagram, white dwarfs are found where? Yes, number D is correct. That is the left corner below the main sequence. Question 15. Which star on the list below has the greatest diameter? So, yeah, the giveaway is this part over here. So, yes, you are correct. The correct answer is number D. Question 16. The human body temperature is about 310 Kelvin. What kind of radiation do we emit? We emit infrared radiation. Question 17. Kepler's first law of planetary motion implies what? And that is D. The distance between the planet and the sun changes as the planet orbits the sun. That is D. The distance between the planet and the sun changes as the planet orbits the sun. Question 18. A meteor shower is produced when? Number D. Earth passes through the path of a comet. Question 19. Why are massive main sequence stars not likely to have planets that contain life? So remember, the more massive a star is, the less time it spends on the main sequence. So therefore, these stars are not in the main sequence for too short a time to allow for life to evolve. Question 20. That a moon has no magnetic field implies what? Yes, number D is correct. The moon's core contains little, if any, molten iron. So now we can go to the longer questions. So one of the first longer questions is how does a gas cloud become hot enough to ignite nuclear reactions? And that is easy. We should all know this. And that is, yes, with a shock wave it gets compressed. That is correct. So it is compression. If I can write neatly with my mouse, compression by shock wave. Then give 3 properties of quasars that make them very strange objects. So the first thing is we need to remember quasars are the most distant objects we can observe. So the first thing is they are very far. Second thing is that we read, let me just, where is a eraser? So the other thing is we should also know that Quasars are the most bright objects in the universe we can observe. So yes, they emit very bright light. You are correct. So, sir, are quasars just supermassive black holes? Yes, they are supermassive black holes that are, well, the correct term is they are active galactic nuclei. So they are supermassive black holes that have a lot of infalling matter into it, and that is why they are extremely active. So with question 22, so very far. And so the second point is they are super luminous. So is there another word to use rather? So AGN, active galactic nuclei. Yes, there are a few slides on quasars. They are under active galaxies. The lecture on active galaxies, more precisely active galactic nuclei. And then the last thing is that we need to understand about quasars is they are very small. Are you guys happy with this answer and what a quasar is? Awesome. So, question number 23. What would you see if you were on the and facing Earth when people on Earth saw a total lunar eclipse? A new Earth, almost. So one thing you would see is, because the shadow of the moon will fall on Earth, so you would see a dark Earth, but you will still have a bit of sunlight going around the moon, shining around Earth. So you will have a red fringe around Earth. Then question 24, this one you should also have familiar with, is what advantages does a large diameter astronomical telescope have over a small one? So question is a red fringe because of diffraction. Yes, that's exactly the reason. It's a bit of diffraction of the sunlight going around the moon that's penetrating to the outer edge of Earth's atmosphere, and that causes a red fringe diffraction pattern. It's a pleasure. So, what advantage does a large diameter astronomical telescope have over a smaller one? Yes, better. The one is better light gathering power. And the other one is better resolution. Then the last question for the mock exam is from what you know about astronomical units in light years. How would you define a light minute? and that will be just the distance traveled by light in 1 minute. So you see, the questions is straightforward. Do you guys have any questions? So you didn't really emphasize much on tasting us on Jovian and a terrestrial planet. Should we still expect much or something like that in the test? Yes. So back to question 9. Okay, let's go back to question 9. So it seems like the exam is repeat of the test on content. Will it be like that on Wednesday? Yes, more or less the same. So question 9. Yes, what about question 9? So how do you decide which values to substitute into the equation? Or does it depend on the question? I mean, what order to substitute them in? It depends on the question. So one thing you'll know from the equation is if you use it, we already know this one is larger than this one. So that means star A is fainter than star B. So that will already give you how to plug it into the equation to get a fainter answer. So since we are not many people in this lecture, so it should be 15.4. Yes, that is correct. It's a pleasure. Since we are only 22 people online, would you guys want one more hint for the exam? So, one more hint is know the Drake equation. So I'm going to type it into the chat as well. The Drake equation, chapter 20. So, only hint I'm going to give you is know that equation by heart. Also know what every symbol or variable in the equation means. It is a pleasure. So tomorrow night I will have another recap or question and answer session again, same time. So if you prepare for the exam tomorrow and you stumble across a few more questions, I will be available tomorrow, same time, if you need any help. Do you guys have any other questions? So can you please do question 9 and I think 2 with the formula? Okay, so question 9, what do you mean with 2? Question number 2 or just question number 9? Question 2, question 9. Okay, so let's do question number 9 first. So which is the formula that we will be using? So the formula we will be using is FA over FB equals, then it will be 2.51 to the power MB minus MA So let me just get my bearings straight with this question. So we're going to do this way. So it's going to be 2.51. Sorry, this one made one mistake. Not brush. I want an eraser. So that's MA minus MB. So now we're going to have MA minus MB. So now we're going to have 15.4 minus 12.4. If you plug this into a calculator, this is 15.81. So we can round this as 16. And because star A, this is a bigger value than this, it means star A will be fainter, so therefore it is 16 times fainter. Oh, the MB and M are absolutely confusing. Okay, cool. So now you also asked for question number 2. So question number 2, it's exactly the same thing. So if we do this, it's going to be again FA over FB, and that's going to be 2.51, and that's going to be to the power, let me just check, so now we're going to write it. So you don't want to have to the power a negative number. So in this instance, it's going to be MB minus MA. So that's going to be 2.51. That's going to be 15.4 minus 13.4, and that should give us 6.3. And we know this one is a smaller number than that one, so therefore it is brighter. So will then always be the larger value subtract the smaller one. And how would you determine the inverse by magnitude of what A is fainter brighter than B? So yes, you will always do the bigger number subtract the smaller number, and it would be exact same principle the other way around. So if you do this the other way around, we can say star A is 6.3 times brighter than star B, or star B is 6.3 times fainter than star A. Yes, it's a relationship. Certainly, please elaborate a bit on magnetars and supernovae, and how can we explain how dark matter and energy interact in the universe? So you're a bit overthinking how this can be answered. So a supernova, the only thing you need to know is that's a supermassive star. At the end of its lifetime, it blew off its outer layers and its core collapsed into a black hole. And that outer layers that was blown off is the supernova explosion. That's the only thing there to remember. A magnetar is, to remember, the same we have a neutron star. A certain type of neutron star is a pulsar that flashes energy like a lighthouse. A magnetar is almost like that, but now instead of its gravitational energies, it's a very, very, very dense object with intense gravitational fields. And then dark matter and dark energy interact in the universe. So all we know is a third of all matter in the universe is dark matter. That's the only thing you need to know. Another question, sir, to clarify for question 15, it's just that a lower number is greater diameter. Yes, that is true. That's question number 15. So with that, remember those are the different classes of diameter. So a class 1 will have the greatest diameter, and a class 5 will have the smallest diameter. Pleasure. Do you guys have any other questions? So the letters, you can use it for temperature. So it's not true. So temperature is proportional to luminosity as well, but it is O, B, A, fine, guy or girl, kiss me. So O-type stars that's the hottest temperature. M-type stars, the lowest temperature. But also, O-type stars is more luminous than M-type stars as well. Does that make sense? Pleasure. Anything else you need help with, sir? I have a question about semester test that we wrote. Yes. So the question that asks what property can be determined from its color? Yes. Is it wrong to have referred to it as temperature, or should it be phrased correctly? Ideally, it should be phrased correctly. So let me just open up the semester test. So I can help you correctly. So what property of a star can be determined from its color? So if you know the color, you can determine its temperature. So I generally try to mark fairly. So if the wording is 70% there, I will get you the mark. So what's the easy way to answer questions regarding arc seconds, etc.? Or how can we remember how it works? So I won't ask you a direct question where arc seconds are involved. It's a pleasure. So it's not necessarily about the correlation between the temperature and color, more generally that it can be determined. Yes, that is correct. Because we can measure that in a lab. Are the questions brutal? No, it's not going to be brutal. It's the same standard as the semester test and the same type of questions that we did in the mock semester test and mock exam. Is it true that hotter lower wavelength, that it means hotter low wavelength and cooler high wavelength, or not? No, not necessarily. So there it has to do with colors. So if you just look at the colors on the EM spectrum, you'll see that they have a set wavelength. You guys feeling okay? Yes, I thought that generally lower wavelength mean harder star. No, that's not how it works. So, ladies and gentlemen, if you have no more questions, you're more than welcome to log off. I will also now upload the recording to YouTube as well. So, the one thing is to remember, we can measure temperature in a lab, and a certain color represents a certain temperature. But remember, you cannot put color and temperature on the exact same scale. So remember, color is visual light that forms part of the electromagnetic spectrum. Temperature is not on the electromagnetic spectrum. Therefore, for example, we know green light is roughly 540 nanometers. So that means when we are looking at a green star, that green star will have a wavelength of 540 nanometers. So we cannot use the wavelength to determine its temperature. But if we are in the lab and we take, for example, a piece of iron and we heat it up, it will first becomes yellowish, and we can measure the temperature. It becomes reddish, we can measure the temperature. It will become white, and we can measure the temperature. It will become blue, and we'll measure the temperature. And therefore, because we can measure it in a lab, we know how hot, what a temperature of different stars is. Does that make sense? Yes, there are certain standards for it. So yes, there are certain standards how that was calibrated in a lab where you know what temperatures, what color certain temperature is. It is a pleasure. So I'm also going to log off now. I'll be available tomorrow from 6 to 7 o'clock again tomorrow night if you have any more questions. Otherwise, have a wonderful evening. Good luck if you write any other exams tomorrow. Otherwise, good luck with preparations.